The tweeter has this felt pad here around the base of the horn where it attaches to the reproducer. I have no idea what that's there for. Here's a stratosphere tweeter. Just taking a look, going around it. And the housing here, or the support for the speaker, are all the audio transformers, transformers, coupling capacitors. This wire in the front here goes to a switch to turn the tweeter on and off if you don't want to hear those high frequencies coming out. The wires in the back go to the right and left woofers. And that's pretty much it for this tweeter. It's a horn type speaker. The tweeter driver board has been reinstalled in the tweeter base and the wires terminated. Also tied off all of the wires so they're bundled together and it'll flop around. I'm adding these rubber grommets to have the tweeter driver board float. I have this one rubber grommet here and just adding these two others. The audio signal generator, the oscilloscope, tweeter speaker, and a tweeter driver are all set up for testing to see the frequency response. The output transformer is connected to the driver board, and the audio generator is connected to the across the output transformer as input to the driver board. The oscilloscope is connected on input and output of the driver board, and the output of the driver board is connected to the voice coil of the tweeter, so everything is properly loaded. So what I'm going to do is run the audio generator from 10 Hertz where it is now up to 20,000 Hertz to see the frequency response. Right now we've got 15 volts input to the driver board at 10 Hertz, and the output is 0, as it should be. I won't be making a video of the whole frequency response. I'll just take notes and create a curve for the report. The restuffed caps have been remounted on the tweeter driver board. Only took 15 minutes to stuff these 4 caps. The 1000 volt rated 0.02 microfarad caps are ready to stuff into the shells of the old caps. The shells have been stuffed with the new capacitors, waiting to seal the ends. Wires have been dressed inside of the base of the tweeters. Looks a lot neater than what Zenith did in the factory. I've removed these 4 paper caps from the tweeter driver here. Tweeter driver has 3 transformers inside of it and some 2 mica caps, and then these 4 paper caps. I removed the capacitor from the shell. These are all the capacitors that were inside. And this capacitor I've already stuffed. Just need to seal the ends up of it and then mount them back on the board. I added Gorilla Tape around the new capacitor so that it fits in tightly into the shell, and then the leads will come out centered. Speaker wires look like they were originally bundled together with electrical tape, but the tape looks more like a black, thick paper. It's not cloth tape. Some of them were missing, like on this side, so I used my wax cord to tie the wires into a bundle. I added one in the middle here just for keep the bundles together. Looking up here, I just added another tie where the speaker wires head into the support box where all the audio and transformers and coupling capacitors and tone bypass capacitors are located. Next, I'll open up the speaker terminal that goes from the amplifier here to this tweeter speaker. I remove the cover for the terminals that connect the speaker wires from the amplifier. I was looking at these, some of the paint's on there. You can see some white, red, green, yellow. That chip looks like it came all the way off, and then black. But thankfully someone scratched into the base what all the wire colors were, so I'll be able to get the correct paint and put paint on these terminals and then also on the ends of the wires so they can be identified and connected to the correct terminals. Here are the original colors for color coding terminals at speaker wires: blue, green, black, and yellow. I'll try to clean these up, but I want to see if I can match the paint to put a little bit of paint on each of the leads so that they can be identified with the terminal that they go to. Here's the underside of the tweeter base with the transformers and coupling capacitors. What's interesting here, this is the output transformer. The unit is supposedly rated for 50 watts output. Maybe that's a peak output. This transformer only looks like it handles maybe 10 to 12 watts. And the 845 tubes has the capability of outputting 12 watts continuously. So really this unit's only rated for a 12 watt output, not 50 watts.